start on arrays. So it seems most of you do remember arrays. Some of you probably don't. So where exactly do you use arrays? Who could tell me? Where would you use them? Why would you want to use arrays? What was that?
Large files.
Okay, same data types. So same data types, yes. Okay, so if there's if you're using variables that are the same data type, then you may want to use an array instead of that. What was that? Okay, avoid repetition, exactly. So you don't want to be declaring, like 10, 20 variables. That's where arrays are going to be far more beneficial. So we're going to go over what arrays are, why C++ is like any other language in terms of arrays. You need the same data types, where it allows you to store the same data types, how to be able to assign values into an array, and how to be able to read values from an array. Also multidimensional arrays. How many of you have done multidimensional? Was this in the 142 class or the 143? Which class? 142. So you did 2D arrays? Okay. Some of you probably haven't, but we'll cover that. So the main thing you need to remember is there's problems with multiple variable names. So some of you may be declaring variables of the same data type 10 times. Is that viable? It's going to be more time consuming in terms of typing the content and also assigning values. So you've been asked to design or think of how 100 names could be held in a computer memory using variables. How is it possible? So most of you are going to do something like this. You're going to say int name 1, int name 2, int name 3, and so on. Eventually, 100 variables. The drawback on this is it's going to take you a long time typing this in and assigning values. So what if you had 1,000 names? You could probably do 100. If you had 1,000, you're going to think, geez, that's just too much. It's just busy work, so you should try to avoid that. So to avoid that, you generally need to come up with some kind of an option explicit approach, which would actually ensure your time is spent more on programming rather than just typing or declaring variables. So what you generally do is you are going to declare arrays. And one thing about arrays is they all have the same data types. That's one thing you need to remember. So arrays are capable of holding a collection of data of the same data type. So you could have an array of just strings, an array of just characters, an array of booleans, an array of integers, and so on. So to declare the array, here we have int, and this is the name of the array. And what is this known as? Who wants to tell me? Index, exactly, index. So this tells us how the dimension of our array, how large is it going to have? How large is it going to be? How many memory locations are there going to be? So in terms of Microsoft Press, an array is a variable that contains a finite number of elements that have a common name and data type. Each element of an array is identified by a unique index number, and changes made to to one element of an array do not affect the other elements. So you could store unique data in each array element. So how do you go about declaring this? So this is basically just a simple idea. So we could have 5 houses, and each so this the array is identified by house, and here we have the index. So every array is always going to start with a 0. So in the very first array element, house 0, it shows us that there's 3 individuals, and the next one there's none. So the way it's going to be structured, you're going to have the variable, you're going to have the index number, and the value that's going to be stored in each array element. So here we have house 3. It's actually got 4 elements, because remember the array will always start from 0. So in C++, just like any other programming language, you're always going to define or specify the data type, and then the variable, and the index itself. So how do you assign values to an array? So there's two options here. You can actually do them in sequence. You could specify the array name followed by the index number, and you can assign the value. So here we're basically initializing our array. Once again, the one on the left is it's time consuming, but on the right, the option 2 is an iteration, which is a loop. So everyone has done 4 loops. So here we're just going through the loop, and we're assigning 0 into it. So we're just initializing our array. So remember, any variable or an array, you need to initialize it prior to using it. So the advantages of option 2, it's less time consuming in generating code. It's efficient and tight code. It's simple and it's not too lengthy. And it's going to be more likely to be error free. So the less code you have, the less errors you're more likely to have. And it's standardized programming. So let's have a look at this particular code here. What do you see here? So we've declared an array, and we have a for loop. So what exactly is happening at the top? What's the difference between the two? Is it? What are they both doing? So what are we doing here? We're actually populating the array. We're going through the for loop, and we're populating with any number that you may want to type in. So it says input a number, then it shows you what the loop value is. So we're going to start with 0. Then we enter something into our array, which we're assuming we've declared. So we go through this 10 times, we throw in some data, and then the loop at the bottom, we have a loop that's going to still run exactly the same, and it's just going to output whatever is in our array. Does that make sense? So that would so what exactly is this one doing? What is that doing? Yes. Exactly. So yeah. So what we have at the top, we have the integer. The loop is basically going to it's going to be a counter that's going to cycle through the array. The array in our case is going to be called entry. The data type is going to be of int type. It's going to cycle through the for loop and allow the user to input the data into our array, which is called entry. Then following that, at the bottom, we have a loop that starts from 9 and goes all the way through to 0. So it's going to show our data in descending order, not the order that the data was typed in, because a loop is also decrementing. So that's the only difference here. And there we just output the data, and as we cycle through the loop. So exercise. So here we have, you don't need to do a 2-dimensional array. So we'll just start with a parallel array. A parallel array is just 2 one-dimensional arrays that sit side by side, because the index numbers are going to be exactly the same. So here we have a student number and a class attendance percentage. So I'd like you guys to create an array whereby you can enter the data or it can be populated from the code, and you're able to also output that. I've also given a two-dimensional setup. So if you wanted to create a two-dimensional array, you would say int students 5 by 2. So the way that would be represented. So here we have a one-dimensional array. So right at the top, here we're declaring a standard integer variable. Then we're declaring an array, which has an index of 5. So it's going to have 5 elements starting from 0 onwards. And then we have this loop. This loop is actually going to allow us to cycle through these 5 memory locations that we've declared, and the index will allow us to identify where exactly we want to put that in. So initially we're going to start with 0, and remember all arrays start with 0. So it's going to cycle through each of these memory locations, and it's going to populate whatever data you type in. So whatever data you type in is going to be thrown into the memory locations. Then following that, we have another loop. It's exactly the same as the loop that we created earlier on. And it's going to cycle through each of these memory locations, and it's going to output the value that you typed in. Okay, in addition to that, there's a part that I've annotated here. So this just takes care of if you want it in descending order, so the other way around. So we have this loop which is going to start from 4, and it's going to keep going down, and it's going to decrement each time. So when we run this, so I'll just type in 5, 4, 3, 2, 1, and it shows us the content that, or the data that are typed in descending order. So this is just a one-dimensional array. So remember, if you can recall, the exercise was to create an array or parallel arrays, two arrays, one next to the other, which will allow us to store also the attendance. So how can you expand on that, basically on a parallel array? So we could create another array. So currently we had entry, so we could have another one for, say, attendance, and I could say 5 again. So we've got two arrays now. So all I'm going to do here is I'm just going to copy and paste, and I'm just changing this to @ for attendance, and I'm going to put enter student attendance. And once again, the output is going to be virtually the same, but this time I'm just going to have data from the attendance section. So now that's all it was, that's all we had to do. So if we run this, hopefully this should work. So we've generally got parallel array. So it says enter student number, so I'll enter 1, attendance was 100, 2, 90, 3, hardly attended, 4, 100, 5, 100, 5, 100. And there's the data. So we generally just have a parallel array. So that's fairly straightforward when it comes to programming. Now if we wanted to have a two-dimensional array, that's going to be slightly different. Here we're going to generally have two. So we're going to have two columns. Two columns. Now how would that work out in terms of the code? So obviously there's some typos here, so generally we would need to include another index next to it in order to take care of the two-dimensional. So initially it would be 0. I mean, there's two ways of doing this. Say if we just had the student attendance, then we could have the next one could be 1, and this would generally be entry, not attendance, because we do not have attendance any longer. And we do the same thing here. We have entry, and we could have 0, and 1. In addition to, so we'd have the 0, 1, but we would still need another index, which would be the loop, and the loop variable will take care of that. So now if we look at this, so generally the way this is going to be, we generally have, we're going to have rows and columns, so we're going to have a number of wonky rows in this case. We're going to have columns. So it's always going to start with 0, and the second column is going to be 1, the index. The first row is going to be 0, 1, 2, 3, and 4. So now when we populate, initially loop is going to be 0, because loop always starts from 0. And the second index is also going to be 0, so we're going to refer to this cell here. And now when we go to enter the student attendance, loop is still going to be 0, so we're still on the very first row. But our second index is going to be 1, which would refer to the column, the second column. So once again, when we cycle through this, our loop counter is going to be 1. So now we're going to hit the second row, which is here, and then we do 0, which is this, and the second column is going to be 1, and we cycle through this. And now when we work the other way around, it's the same concept. We're going to start here, 4. We're going to display column 0, column 1. Now when we run this, it's going to function exactly the same as we had the parallel arrays. Okay, so that's how you do parallel arrays and 2D, two-dimensional arrays. Now if we move forward, so how would it be possible to display the array in descending order, which we've already covered? So you just have the loop that's going to decrement. So you're now required to create or update the program that you have, but this time you're going to have student ID, credits, and GPA. How would you tackle that? So it's still a 2D array. So we're just going to have another column at the end. So how would you do that?